All right, hey everybody, we are looking at section 12.4, which is inscribed angles. An inscribed angle is an angle whose vertex is on the circle and the sides are chords. So if I look at this, my whole angle is contained within the circle. It's kind of Pac-Man-like, okay? So E is the vertex of my angle, DEF, all right? It hits arc DF. So that's the intercepted arc is arc DF. All right. Those are the endpoints of your sides of your angle. Okay. So the angle intercepts the arc. All right. The arc subtends an angle. So that's kind of what that's the vocabulary for if we do it the other way around. So I can say that angle DEF intercepts arc DF, or I can say that arc DF subtends angle DEF. Okay, so that's just kind of the different verbiage and vocabulary on how we say those. Okay, an angle DEF is an inscribed angle because, again, its vertex is on the circle and both of its sides are inside the circle. All right, so let's take a look at some of the information about inscribed angles. Okay, an inscribed angle is going to be half of the measure of its intercepted arc. So when we look here, our inscribed angle can either go through the center, go around the center, or be all on one side of the center. It makes zero difference. Okay, it's all the exact same thing. All three of these are inscribed angles. Okay, and if arc AC is 100 degrees, then this angle is going to be half of that. So this angle here would be 50 degrees, okay? So that's all that this is saying is the angle, the inscribed angle, is going to be half the arc. Now, if I have several angles intercept the same arc, so look at my yellow arc AB here. If I look at my red angle, angle ACB, okay, it intercepts arc AB. If I look at my blue angle, ADB, this intercepts arc AB. All right, then my green angle AEB also intercepts this same arc. Okay, well, what's going to be true is, again, if I say that this is 100 degrees, and you don't have to write this, we're going to put this in just for sake of understanding. Well, this red angle here hits that arc, so it'll be half. So this angle would be 50 degrees. Okay, well, then I would take a look at my blue angle here, and it hits this arc, so it would also be half, so it's 50 degrees. Then my green angle hits the same arc, so it's also half, so it would be 50 degrees. So what do you notice about these three angles that hit the same arc? Is those angles are all congruent, okay? So anytime you have more than one angle hitting the same arc, those angles are always going to be congruent. All right? This one you don't really need to memorize, all right? Because it's going to be the same thing. If this is 90, then its arc is going to be 180 degrees, which means that this point and this point are the endpoints of a diameter. Okay, and the same thing is true. If an angle hits an arc that's 180 degrees, then that inscribed angle is going to be 90. This is just an extension of the previous theorem, so it's not one that you need to know separately. You do need to remember that an angle is half of the arc. An inscribed angle, excuse me, is half of the arc. All right, now, let's take a look here. If I look at my angle right here, okay, this angle hits this arc, okay, right? So this arc here is going to go with this angle right here. If I look at the angle that is opposite it, if I look at angle B, angle D, okay, so angle D is across from angle B. Here's angle D. It hits this arc. Now, those two arcs together are going to add to the full circle. They're going to add to 360. which means that these two angles together are going to add to half of that. I don't know exactly what they are, but they'll be half, which means that the opposite angles in an inscribed quadrilateral are supplementary. Now, what inscribed means is, remember that each vertex is on the angle. All right, so opposite angles in your inscribed quadrilateral are supplementary. They're going to add to 180 because their arcs are going to add to the whole circle. Their arcs are going to add to 360. All right, so let's take a look at some of that in practice. I want to find the measure of angle RST. So RST is this angle right here. Okay, it hits this arc. So the measure angle RST is going to be half of the measure of arc RT. Okay, because that's the arc that it hits, so it'll be the inscribed angles half the arc. So that means that the measure of angle RST is going to be half of 120 degrees. So the measure of angle RST is going to be 60 degrees. Okay, now for the next one, we are looking, and I want to find the measure of arc SU, which is right here. Okay, now this arc is going to subtend this angle right here. Okay, so that's the angle that has the endpoints that are the ends of the arc. Okay, so I know that the arc, or the angle, is half of the arc. So that means that I can also say that the arc is twice the measure of the angle. So if I do twice the measure of angle SRU, that's going to give me the measure of arc SU. So the measure of arc SU is going to be 2 times 40. So the measure of arc SU is going to be 80 degrees. Okay, let's take a look at some more examples. All right, I want to find the value of x here. Well, notice that I have my angle right here is RQT, and I am intercepting arc RT here. What do you notice about this arc? Okay, you should notice that because segment RT is a diameter, that this is a semicircle, so it's 180 degrees. All right, so that means that the measure of angle, RQT, is half of that. So that means that this angle is going to measure 90 degrees. Okay, because a 180 divided by 2 is 90. So what I'm going to do here is I'm going to set 4x plus 6 equal to 90. All right, we're going to subtract 6 from both sides. We're going to get 84. And then we are going to divide both sides by 4. And I'm going to get 21 is my value of x. All right. Then from here, I want to find the measure of angle ADC. So ADC. Okay, it is going to intercept arc AC. Well, I don't have any information here, so let's look and see what other information I know. I see that angle ABC is also going to hit arc AC. A little crazy. Okay, so because my pink angle and my orange angle both hit arc AC, I know that these angles are congruent. So I'm going to set 10y minus 28 equal to 7y minus 1. All right, so I'm going to subtract 7y from both sides. I'm going to get 3y minus 28 is equal to negative 1. We're going to add 28 to both sides, and I'm going to get that 3y is equal to 27. So y is equal to 9. Now, I want to find the measure of the angle. So the measure of angle ADC is going to be 7y, which was 9, minus 1. So 7 times 9 minus 1 is going to give us 62 degrees. All right. Again, if you have any questions, you can kind of note that over there on the left-hand side. And let's take a look at your next one. Okay, I want to find all four measures of all four angles in this quadrilateral. Now, remember, okay, that the opposite sides, or excuse me, opposite angles in an inscribed quadrilateral, are supplementary. So that means that the measure of angle P plus the measure of angle R is going to equal 180. And it means that the measure of angle Q plus the measure of angle S is also going to equal 180. Okay, so those are your opposite angles. So notice that Q has an information here, but S does not, so I'm not going to worry about that set right now. But I have information for both P and R. So P is 6y plus 1, R is 10y plus 19, equals 180. So I'm going to combine like terms and get 16y plus 20 equals 180. All right, we subtract 20 from both sides and get 16y is 160, so y is 10. All right, so what I'm going to do here is start plugging in the information that I know. So the measure of angle P is going to be 6 times 10 plus 1. So the measure of angle P is going to be 61 degrees. So there's one angle. The measure of angle Q is going to be 10 squared plus 48. So that's 100 plus 48. So the measure of angle Q is 148 degrees. Okay, then we're going to look at the measure of angle R, which is going to be 10 times 10 plus 19, so 119 degrees. And you can double check that 119 plus 61 is going to add to 180. Then when we look for the measure of angle S, I'm going to plug in here. We know that Q is 148. And when I subtract that from 180, I'm going to get that the measure of angle S is 32 degrees. So there's all four of my angles. All right. So again, if you have questions, kind of note that down. And again, for what I would like for you to do for this lesson is go ahead and again, I want you to work all three problems of these on your own. Well, four technically. Okay, so work these problems. So go ahead and pause your video. When you're ready, come back and hit play again. Okay, so go ahead and check your answers for A, B, and C. We'll slide it over in a second so that you can check your answers for D. All right, for A, we're looking for the measure of our purple arc, ADC, and it's going to subtend this angle, which is ABC. ABC is 135 degrees, so we multiply it by 2 to get 270 degrees, because again, the angle is half the arc, so the arc is twice the angle. All right, our blue one here, DAE, is the angle we're looking for. It intercepts arc DE, so that's 76 degrees. So we're going to cut that in half to get 38. To find the measure of angle Z, I notice that this is a semicircle, so it's 180 degrees, which means that this angle here is going to measure 90 degrees. So I'm going to set 8Z minus 6 equal to 90, and I'm going to get Z is 12. So again, take a second to kind of look through that. If you need to pause it to get all that information down, please do so now. All right, let's slide over. And here's the information for the measure of angle D. Remember, opposite angles or opposite inscribed angles are going to be supplementary. So angles K and M are going to add to 180. Angles J and L are also going to add to 180. So since there is no measure for J, I'm going to look at M and K and add those up, set them equal to 180. I'll get that X is 16. I'm going to plug that in for angles M, L, and K. Then to get angle J, if this is going to be 72 degrees, I know that these are supplementary, so I'm going to subtract that 72 from 180. All right, if you guys have any questions, please write them down and make sure you ask in class tomorrow. Have a great night.